Hi all, I am Divya Somakumar and in this video we are going to learn about K-means clustering. Now, what exactly do you mean by K-means clustering? To understand K-means clustering, we'll have to first understand what we mean by this clustering term. Clustering is an unsupervised machine learning task that automatically divides the data into clusters or group of similar items. So basically, clustering is an unsupervised machine learning task. What do you mean by this? It means that you have only features in your data. You do not have your target variable. That is, you only have your x variables but you fail to have your y variable. Or you only have your independent variables and you do not have your dependent variable. So basically clustering cannot be used for prediction because you don't have your y variables which you can predict. So clustering is mainly used for knowledge recovery. Now in clustering, it divides the data into clusters or groups of similar items. Clustering is guided by the principle that items inside the cluster should be very similar to each other but different from those outside the cluster. So our clusters have to be as homogeneous as possible, but each cluster should be heterogeneous amongst themselves. So each cluster should be homogeneous from within and heterogeneous with other clusters. Now let's understand what exactly is K-means algorithm. K-means algorithm identifies k number of centroids and allocates each data point to a centroid by keeping the centroid as small as possible. So basically here we are interested in finding the number of centroids, that is k, and all the data centers around any one of the centroid. Now let's understand K-means algorithm using a graph. Consider the following graph. Here you have some green boxes, you have some orange circles, you have some blue boxes and you have some orange triangles over here. These are different clusters for us. Now initially we will set a centroid at a random place. So randomly we'll select a centroid and we'll locate it at a random place. We will measure the distance of this centroid from each and every data point. Now, for measuring distance, we will either use Euclidean distance or Manhattan distance. After measuring the distance from each and every point, the centroid will try to adjust itself to the center of the cluster. As long as it has not reached the center of the cluster, it will go on readjusting itself. So the steps are, first we will place the centroid arbitrarily at any point in the space, and then we will check its distance from each and every point, and then the centroid will go on changing according to their needs and place itself in the middle of the cluster, and this computation will go on as long as the centroid reaches the center of the cluster. Now let's look at the steps involved. The first step is to choose the number of clusters, that is k. The second step is select random k points, that is centroid. Third step is to assign each data point to the closest centroid. The fourth step is to compute and place the new centroid of each cluster. Fifth point is to reassign each data point to the newest centroid. Now, if the centroid has not reached the center yet, it will go to the step 4 again. I hope all the steps are clear for one and all. Thank you.